Hi guys! Welcome sa enginerdmath channel. Sa video na to ay tuturo ko sa inyo ang Superposition Theorem for AC circuits. So kung gusto niyo itong matutunan, just keep on watching. Okay, so this time ay ituturo ko naman sa inyo yung Superposition Theorem for AC circuits. So, tulad sa DC circuits, same lang din naman yung approach na gagamitin natin dito kapag nag-solve tayo ng AC circuits using Superposition Theorem. That is, i-consider natin yung one source at a time sa circuit and then isa-solve natin yung required parameter na hinahanap sa problem, let's say current or voltage, doon sa particular voltage or current source na naka-on. And then, after that, magpo-proceed ulit tayo sa other current or voltage source at i-off natin yung iba. And then, isa-solve ulit natin yung voltage or current na hinahanap din sa circuit. This time, dito naman sa panibagong naka-on na current or voltage source and so on. So, mahalaga itong Superposition Theorem for AC circuits, especially kung yung kinoconsider nating sources ay merong different frequency or angular frequency. Kasi kapag magkaiba yung frequency nung ating mga sources is magkakaiba rin yung magiging equivalent impedances ng ating passive elements. So, therefore, mahalaga na pwede nating magamit itong Superposition Theorem kapag kinonsider natin yung voltage sources or current sources sa circuit na may magkakaibang frequency. Kasi hindi natin pwedeng i-combine in phasor form yung mga voltage or current source na magkakaiba yung kanilang frequency, right? So, kapag ginamit natin Superposition Theorem, one source at a time, is makukonsider natin yung iba't ibang phasor equivalent, particularly sa mga impedances ng passive elements at a particular source with certain frequency. Okay? So, para ma-illustrate natin yung pag-solve ng AC circuits using Superposition Theorem, ay mag-solve tayo ng example. So, sabi, find VO of the circuit below. Okay, so meron daw tayong given circuit na merong tatlong independent sources. Yung voltage source na may value na 10 cosine 2t, yung current source na may value na 2 sin 5t, at yung DC source lang na may value na 5 volt. At hanapin daw natin yung VO o yung voltage drop dito sa 1 ohm resistor with this polarity. Okay, so kapag magsasolve tayo ng AC circuit using Superposition Theorem, isa-sum up natin algebraically yung contribution ng bawat independent sources one at a time doon sa hinahanap nating parameter doon sa circuit. In this case nga, itong VO. So, let's say, pag hinanap natin yung total voltage dito sa V0, we have V1 plus V2 plus V3. Let's say itong V1 yung contribution ni 5 volt, itong V2 yung contribution ni 2 sin 5t current source, at itong V3 yung contribution ni 10 cosine 2t voltage source. So, let's start with finding V1. So, ibig sabihin, ang ititira nating source is itong 5 volt DC source lang. And then, i-off natin itong current source na 2 sin 5it. Kapag meron tayong current source, in-off natin yon. Ang ginagawa natin yung 0 by making it an open circuit. Tapos, ito namang voltage source, i-off din natin by making it a short circuit. Okay, so kung mapapansin nyo, ito palang ating independent sources ay magkakaiba ng frequency. Right? Kasi itong DC source natin is 0 frequency yan, right? Tapos itong 2 sin 5t ampere natin, yung angular frequency niya is itong nakamultiply sa t na 5. Tapos itong 10 cosine 2t voltage source, yung angular frequency niya naman is 2. So therefore, mahalaga nga yung Superposition Theorem kasi dito sa example natin is iba-iba yung kanilang frequency. Okay, so sige, let's start muna dito sa contribution ng 5 volt dito sa Vout. Okay, so redraw ko kapag ginawa natin yung pag-short at pag-open ng other independent sources. So, para dito sa 2 sin 5t, sabi ko nga, i-open natin. So, i-open ko siya. Okay, so parang wala na siya. Tapos, ito namang voltage source natin, i-short ko. Okay, so therefore, ito yung kinalabasan nating circuit. Ngayon, dahil meron tayong DC source, alam natin na kapag ang source natin is a DC tapos meron tayong passive elements na inductor at capacitor, for a long period of time na nag-a-act yung voltage source na yon, anong mangyayari doon sa ating capacitor at inductor? So sa capacitor, magiging open siya, right? So therefore, pwede natin siyang i-delete. Remember yung video ko about capacitors. And then, kapag inductor naman, mag-short siya, right? Remember din sa video ko about inductor. So therefore, anong natira ngayon sa atin? Ito na lang, series na 1 ohm tsaka 4 ohm resistor. Okay? So pwede natin ngayon ma-solve itong VO due to the contribution of 5 volt source by voltage divider, right? So therefore, VO is equal to, so mapapansin nyo, magka-opposite sila ng polarity. Kasi yung current na ipoprovide nitong 5 volt is this way. Since papasok ngayon tong current na to sa negative nung polarity ni VO, therefore, negative yung magiging sagot natin dito. Okay? So, therefore, VO is equal to negative of 1 ohm over 1 ohm plus 4 ohm times 5 volt. So, ilan to? Voltage divider lang siya, right? Negative 1 volt. Okay, so therefore, ito yung V1. Yung contribution ng 5 volt DC source. Okay, next. Hanapin naman natin yung contribution ng current source V2. So, copy ko ulit itong circuit. And then this time, ititira ko si 2 sin 5t current source, right? So, i-off ko si 5 volt DC source. So, masu-short siya. And then, si 10 cosine 2t voltage source din, i-off ko by shorting it. So, therefore, ito yung natira nating circuit. So, mapapansin nyo, yung ating current source is 2 sin 5t, which is hindi siya naka-cosine, right? So, para ma-convert natin siya into cosine, kailangan nating mag-minus ng 90 degree. So, equal siya sa 2 cosine 5t minus 90 degree. So, pag tinransform natin ngayon siya into polar form, 2 angle negative 90 degree. Okay? So, transform din natin itong mga passive elements into their impedances. So, gamitin natin yung omega ng ating voltage source na 5. So, para dito sa 2 Henry inductor, we have ZL is equal to J omega L, right? So, we have J times omega is 5 and L is 2. So, 10 J or J10. Yung mga resistor, same lang, right? Tapos dito na lang sa capacitor, we have ZC naman is 1 over J omega C. So, we have 1 over J omega is 5 times capacitance is 0.1. So, using calculator, ilan to? Negative J2 ohms. Okay? So, ngayon, pwede na nating isulat yung impedance nitong capacitor at inductor in terms of J. So, meron tayong J10 sa inductor, tapos negative J2 ohm sa capacitor. Okay, so ngayon, paano natin mahanap yung VO? So, mapapansin nyo, pwede natin gamitin dito is yung current divider. So, i-combine lang natin muna itong parallel impedance na to, na capacitor, tsaka yung resistor. So, equal yan saan? Let's say Z1. So, formula for parallel impedance is yung product nila sa numerator divided by yung sum nila, right? So, 4 minus K2. So, using calculator, ilan to? 0.8 minus J1.6 ohm. Okay, so therefore, yung impedance branch nito is i-add natin yung 1 ohm dito sa Z1. And then, parallel na siya dito sa J10 ohm. So, pwede natin gamitin yung current divider rule. So, makasolve natin muna yung current muna dito sa 1 ohm resistor as, let's say, I1 equal, so, di ba kapag dalawa lang yung branch natin, ang ginagamit nating shortcut is yung impedance ng isang branch, yung hindi natin kino-consider, over yung sum nung branch na yon, tsaka yung kino-consider nating branch. So, therefore, we have J10 plus, di ba, series itong branch na to nung 1 ohm tsaka nung J1. So, we have 1 plus, itong nakuha natin, 0.8 minus J1.6. Okay, and then multiply natin sa current source na 2 sin 5t or yung na-transform natin as 2 cosine 5t minus 90 degree or in polar form 2 angle negative 90 degree. Okay? So, equal to sa J10 over, so 1 plus 0.8 is 1.8 and J10 minus J1.6 is positive 8.4J times 2 angle negative 90 degree. And then, para masolve natin itong VO, multiply natin sa resistance niya na 1 ohm, Ohm's law. So, therefore, yung V2 is positive siya kasi nagko-confirm naman yung direction ng current source dito sa sign ng voltage dito sa resistance, passive sign convention. So, we have, etong nakuha natin na to, so J10 over 1.8 plus J8.4 times 2 angle negative 90 degree times yung resistance niya na 1 ohm lang. So, parang times 1 lang. So, parang ito lang din pala. So, using calculator, input natin to, then gawin na lang nating polar form. We have 2.328 angle negative 80 degree volts. Okay? Or, kung ibabalik natin, in time domain, we have V2 is equal to 2.328 cosine 5t minus 80 degree, right? Volt. So, balik natin in terms of sine kasi yung original natin is in terms of sine. So, ang gagawin lang natin is mag-a-add ulit tayo ng 90. So, 2.328 sine 5t minus 80 degree plus 90 degree, we have, ilan na to? 10. Positive 10 degree volt. Okay, so ito yung V2. Next, dun naman sa contribution nung voltage source na 10 cosine 2t. So, copy ko muna uli. And then, i-retain natin tong 10 cosine 2t volt. Then, i-off natin tong current source. So, magiging open uli siya. Then, itong 5 volt DC source, magiging short naman siya. Okay? So, mapapansin nyo, itong voltage source natin is in terms of cosine. So, pwede nating agad directly i-transform into polar form as 10 angle 0 degree. Right? And then, ito ding mga capacitor at inductor is i-transform natin into their impedances. So, dito muna tayo sa ZL. J omega L. So, this time ang omega natin is yung nakamultiply sa T na 2. So, 2. So, we have J times 2 times inductance na 2 is 4J. And then sa capacitor naman, we have ZZ is equal to 1 over J omega C. So, 1 over J, same omega na 2, and then yung capacitance nga na 0.1. So, using calculator, ilan to? Negative J 5 ohm. So, pwede ko nang isulat in terms of their impedances as itong inductor J4, tapos itong capacitor negative J 5 ohm. So, paano ngayon natin masasolve itong V0? Pwede tayong gumamit ng voltage divider. Pero pwede muna natin itong i-simplify as a single impedance law kasi parallel sila, right? Para in series na lang yung tatlo. Okay, so pag ginawa natin yon, let's say Z1, parallel sila, so product sa numerator, so negative J5 times 4 over sum, negative J5 plus 4. So ilan to? 2.439 minus J1.951. Okay? So, para masolve natin ngayon tong si V0, voltage divider, kasi in series lang naman tong tatlo, right? So, therefore, V3 is equal to yung resistance nitong 1 ohm, so 1 over yung total resistance ng circuit, which is yung J4 ohm plus itong 1 ohm plus itong combination ng parallel impedances na ito, yung nakuha natin, 2.439 minus J1.951. And then, multiply natin sa voltage source na 10 angle 0 degree. Okay? So, using calculator, ilan to? In polar form na lang din, 2.498 angle negative 30.79 degree volt. So, transform ulit natin in time domain. In terms of cosine, we have V3 is equal to 2.498 cosine 2t minus 30.79 degree volt. Okay? So, therefore, yung total VO is equal to V1 plus V2 plus V3, right? Ano yung V1 natin? negative 1 volt. Negative 1 plus, ano yung V2 natin kanina? Ito, 2.328 sin 5t plus 10. 2.328 sin 5t plus 10 degree. And then, yung V3 natin is 2.498 cosine 2t minus 30.79 degree volt. So, therefore, ito yung total V0 natin or VO natin para dun sa 1 ohm resistor using superposition theorem. Okay? So, I think that's it for this video, superposition theorem. So, sana ay may natutunan kayo sa video na to at maraming salamat sa panonood.